Good morning and good afternoon. Hope everybody can see me. We're very excited for this webinar today. We're going to be talking about really a new concept as well as a new product that we're offering as Bespoken. So it should definitely be a fun one. Before I get started, just a few notes. We do record these webinars, so we will send you that recording afterwards. Additionally, all the slides that I go through, those will be available. So you don't need to frantically take screenshots or anything like that. We'll send that all along. We have the chat and the questions tab that you'll see here. If you have questions as I'm going through the presentation, please feel free to enter them there. I'm actually watching these on Slack on my phone, so our Bespoken team is actually in that chat window, and they'll send it to me, and I'll do my best to answer it as I go through. And it's probably gonna be a little bit shorter today, so we'll give you a little bit of time back. And before I jump into it, I guess just the one other note I would make for those of you that have been on our webinars before, we have a new banner, which we think looks great. It has the new llama. I don't know that we came up with an official name, but we're kind of going with Robo Llama for the moment. I think it looks really cool. Very excited about this banner. Not as exciting as new products, but we think it looks great. And so with that, I'm going to jump in here. And hi, everybody. I see a lot of folks that I know there, so nice to see you, and thanks for joining us. All right. So I'm going to share my screen, and I'm going to turn off the video here. All right. So this webinar is about usability performance testing. As I mentioned, this is a new concept as well as product that we're introducing that we're really very excited about. And so what we're going to go through, we have some introductions. We're going to talk about why usability testing is critical for voice. We're going to go through our approach to it, do a demonstration, talk about some of the data that we've seen so far and go through sort of a preview of that and some of the case studies that we're working on, and then finally talk about next steps and how you can take advantage of what we're offering here. So just some introductions. I'm John Kelvey. I'm CEO of Bespoken. Additionally, in our chat window there, I think you'll see Diego Martin, our product manager, Fiorella Casavilca and Karen Guerrero from our marketing team, and then Guy Bergford, who leads our business development. And feel free to say hi to them. They're a very friendly, smart group of people. So what do? We provide monitoring and testing tools for voice apps. We've been recognized by both Amazon and Google. We support both those platforms. We monitor over 1,000 apps. We have over 4,500 developers using our tools. And I personally have a long history with speech recognition and AI. Prior to Bespoken, I was actually building my own speech recognition system that did advertising, audio advertising on mobile. And I learned a heck of a lot about building for AI doing that. And really, we've tried to transfer that into what we're doing at Bespoken. And quite specifically, what we're talking about here, the usability performance testing, it was really an essential part of building a speech recognition system. What we had was large data sets of tests or audio samples to run through to ensure the performance of what we're building. And that experience, I think it translates pretty closely to what we're doing here and what we're offering. We really think that that's the optimal way to handle building for AI. And we'll talk through more what that means and as we go through these slides. So why does usability matter? Why is it so important? So one, there was a recent survey that came out talking about the most important qualities of a voice assistant. And the number one capability people wanted was improvements for how well it understands them when they speak. That was the biggest concern. And I don't think that's a surprising result. On one hand, perhaps we're expecting specific feature requests or particular products, but these devices are already quite feature rich. And I think for those of us that are regular users, there can be this frustration when it doesn't understand you. And obviously the state of the art of AI has improved, I would say, dramatically. I frequently think back to 2013. I was really doing some in-depth research of what was available in terms of componentry for speech recognition. And the comparison between what was available then and what is available today, it's improved by leaps and bounds. And the teams at Alexa and teams at Amazon and Google, I think they've done an incredible job of really popularizing speech recognition and voice assistants. But, and this is what the study is showing, more improvement is still needed, and it's a frustration point for users. And it needs to be something that people who are building voice experiences really take into account. And all that, we're just speaking generally, a couple specific scenarios that can be challenging, definitely accents, quite specifically, talking about non-native English speakers, the performance there can really do much worse. We see this very frequently. We're a company that's based in Peru. We have many non-native English speakers who are excellent speakers, but definitely we see that Alexa does not understand them as well. So this is a common thing. It may represent a large part of your customer base. And for those folks, they really may not be having a great experience. So that's something that people building for voice really need to keep in mind. Additionally, the environment. This is really a critical factor for the performance of these apps. If there's background noise, whether it's just ambient noise, like in a car, you have road noise, if it's people speaking, if it's a noisy office type environment, all of those things are going to impact the performance of your speech recognition and the AI in general. So those are additional factors that you really want to look at when you're testing, especially if you know that those are really common use cases. And you know that those are patterns for how users are interacting. And then just, a few anecdotes from customers and folks that we've been working with on this that I think are sort of interesting around these challenges. One game developer for voice mentioned that the primary way that he gets feedback where there's speech recognition and interaction model issues is seeing 1-star reviews after the skill gets through the whole submission and certification process. And so it's just launched, and then you have users come in and saying, hey, this thing that used to work, it's not working anymore, or it's not working for me in this particular way that I'm interacting. That's really not a good diagnostic tool. You don't want to be using the Amazon skill store and the review system there as your way of collecting data on user experience. Similarly, talking to some folks who provide a voice-enabled music service, the primary channel that they're hearing about issues around recognition is through customer support. Could be somebody calling, chat, could be through a review, but it's coming in through these different channels, and there's not any real systematic way to test it on their own. And then finally, just in terms of what people are doing today to try to chip away at this, in the absence of really industrial strength tooling, it's a lot of manual testing. And that manual testing is very tedious. It's typically not going to be comprehensive. People try to cover key scenarios and go as far as they can with it, but I think most folks know that they're really just scratching the surface, doing manual in-house testing. So these are all things that our customers are seeing and challenges that they're having with the usability testing. We're very pleased to offer what we think is a much better way to do this. And so the way, what we're offering, we've called it usability performance testing. And it's really about measuring the performance of your skill's usability. I mean, that's a pretty plain way to say it. And we're making sure that the speech recognition and the NLU are working correctly. We're interacting with Alexa and or Google Assistant using spoken audio, and that audio can come from a few different sources. It can be generated audio. We use AWS Poly or Google TTS, or actually should be End. We use both as part of a single test. We can use crowdsourced audio. I actually think some folks from Applause, our partner, are on this webinar. We've worked with them around gathering audio from large sets of real users and real world scenarios. That's a fantastic way to do this sort of testing. And then you can actually use audio from production systems. Can't be audio from an Alexa or Google Assistant production system unless you happen to work for one of those companies. But if you have deployed voice in other environments, you can be using, into a mobile app or something like that. You can be using that as a source to capture audio from real users. All of these are really helpful techniques. I will say today we tend to focus on the generated audio. That's the easiest for us to work with, and it's the easiest for our customers to work with. But, again, referencing back to my own experience, the crowdsourced audio from production systems, these are phenomenal ways to be monitoring and enhancing the performance of your skill. So both of those are also quite valuable. And then with these data sets, with these sets of test cases and samples, what we're doing is we're just churning them through the assistant, and we're seeing how well it understands what we're saying. So it's really about just getting this data and then pushing it through Alexa and Google Assistant. And so this slide, this might be a bit techy. My background is a software engineer, so I do like to know how things work. The way in which we've built this, we have our usability testing service, and that manages jobs, and the jobs run to test a particular skill. It provides reporting and analytics, and it also provides historical data. And then that in turn relies upon our virtual device service. Again, if you've been to any of our previous webinars, or if you're familiar at all with our product set, you've probably heard us talk about this. But the virtual device is what allows us to interact with Alexa, using text-to-speech, using other audio inputs. It's our core service that it functions like an adapter to really make Alexa easily testable. So that piece, our virtual device service, its primary point of interaction is with Alexa, and I should say Google Assistant itself. It sends audio to those services. Lots of stuff going on in there. I'm being fairly reductive in just saying speech to text and NLU, but those are the core pieces that we think of. They're going to take that audio, do the magic with it, and then forward on the request to the skill. And that skill, what we're doing there, that doesn't actually need to be your skill. We actually have our own, we call it a parrot skill, or it's sort of a dummy skill. All it's going to do is it has the interaction model, has your interaction model, and it's going to see, okay, here's what Alexa understood was said. Here's the intent, and here's the slots that it resolves it to. and it just plays that back then to our usability testing service. So we see, okay, here's what Alexa thinks it heard, and our service then registers that and takes that into its reporting. So it either got it right or didn't get it right, or in some cases it doesn't really know, but just simply basically playing back what that input was. It's really as simple as that. And so then how is this testing different than other types of testing that you've heard us talk about? So I think this is an interesting thing. It's 2019 now, and since it's a new year, we're really thinking about adding another layer to this cake. Hopefully that doesn't sound too bold, going from 4 layers to 5 layers. We do think it's an exciting addition. What we're adding with the usability performance testing, it is definitely additive to what we've already done. It's building upon the pieces that we already have, but it is different. And it's different from automated unit testing, and that automated unit testing is focused really purely on the code and making sure that the code, the logic, maybe external services are working correctly. And that's great stuff, but that doesn't have anything to say about how the AI is performing. The end-to-end testing, that does touch upon the AI. That tests everything. As the name implies, that's testing everything from the AI to the code to external services to even stuff that's, Alexa itself, ensuring that that's working correctly. It's a really comprehensive functional regression, end-to-end test, whatever term you prefer. It covers all those things, and that's extremely valuable. But we think that this additional sort of specialization is also quite valuable, which is the usability testing. And really a way to think about it is that we're putting aside testing the code. So it's different from the end-to-end testing, and then it's not going to touch your code really. And we're focusing purely on testing the AI, testing the interaction model. And so a way to think of it even is that it's unit testing for AI. We're really verifying that interaction model and ensuring its performance. And so what do these testing life cycles look like? It's pretty simple here. The first step is creating a baseline. And we think this is critical. So you have your interaction model. You need to know and have a benchmark for how it's performing. And you should have that before you go and start making changes to it. Once you have that benchmark, then you can iterate and improve on it. So you start making changes to it, and those changes, it could be based on things that come back in that baseline report, where it's showing you things that are not working as well as they should be. It could be, okay, we're going to go ahead and make a series of changes to the skill, and we're adding new behavior. In either case, once you have that baseline, you make the changes, and then as you're making the changes, you rerun the test, and you make sure that it's actually having the effect that's intended. And that's really a critical thing. In terms of the outcomes that you want, hopefully this slide does not seem patronizing. It's really, I would say, a critical thing to keep in mind. You want to obviously be making improvements. Whatever changes you're making should be improving the usability of your skill, improving the user's experience. So the best way to ensure that is by testing it, because you could be adding some stuff to the interaction model and it doesn't have the intended effect. The only way you're going to know for sure is actually testing it. At the same time, you want to make sure that you're not making it worse. And obviously anybody familiar with systems development knows about bugs, knows that there's risk to making changes. But the side effects related to speech recognition, just having spent time in this, I think they're more profound, and they're also more surprising. And so it's very difficult to know, to sort of reason your way to what effect a change is going to have. The only way to know is to test. That is really the answer. And the best way to do this testing, the best way to provide a great user experience is testing that's consistent and comprehensive. And so you need automation, you need tooling like we offer to do that. So with all that set up, I'm going to show you how this works now. And first, a slide though. For the test creation process, just to walk you through what's involved with this. The first thing that we want to know is what phrases are going to be tested. So this could be a slot with a large set of values for it. Could be sample utterances mapped to one or more intents. We want to come up with that list of slot values and or sample utterances that are being tested. That's the first part. And that can be as simple as just taking the interaction model and testing everything in it. That can be a good starting point, and then from there narrowing it down. Once those phrases are identified, what are the variations that we want to test? And so what do we mean by variations? Well, we have a phrase, and let's take a case of the sample skill that I'm going to demo here. So we put together a skill we call travel advisor, and it has an intent for go-to destination, and it has a slot value for the destination, which is a city. So if we think about that, where somebody might have an utterance of go to Boston, and we're trying to test that slot value for the city, we can say it. We can say go to Boston in a number of different accents. We can say it in different languages if we're multilingual. We can say it with different genders. There's a lot of variation we can have on the speakers, and that's going to impact performance. We can vary what the phrasing is. So if it's a slot value, we're trying to test Boston, but we might have a variety of different ways people will ask for traveling to Boston. They might say, go to Boston. They might say, I want to go to Boston. They might say, take me to Boston. There's a slew of different phrasings people might use, and the performance can vary on that. Knowing where there's issues is really helpful because one, you want to steer people towards the phrases that are going to perform best, and you can do that with how you prompt users. And you want to steer them away from things that are not performing as well as improve the interaction model where there are issues. And then lastly, environmental considerations. If there's other speakers in the background noise, as we mentioned, these scenarios are also very important to test. And depending on how you're expecting the skill to be used, can really be essential use cases. So then the last thing we need for these tests is what is the interaction sequence? So, two different ways that people might interact with a skill. One is one shot, in which people are saying, Alexa, ask travel advisor to go to Boston. And in that case, they're going to just get their response directly. Alternatively, in session, in which somebody launches the skill and as part of a conversation is saying this intent, that's a different scenario. So what that sort of sequence is, that's an important part for setting up these tests. And we have seen different performance based on whether or not it's a one shot or in session. So this is the information that we need to set up a test. We went ahead and already ran some tests that we're going to show to you. So this is using our sort of dummy skill here. And I'm going to show you the one-shot test that we ran first. And we ran through our skill testing this intent destination with the slot city. We ran through about 1,000 different phrases and running them through with 3 different variations. So it's a little under 3,000 in terms of the total number of interactions, and that's because we're running them 3 variations for every slot value. So that's how you get to that number. And then the performance was about 94%. Now this is a skill I put together just for this example, just put it together actually this week. So we haven't tuned this at all. And so 94% is, that's about where we sort of expect to start without doing any tuning. And if we look at one of these, so these are all the cities that we said, lots of different cities throughout America. And here's the different variations that we have. We say, ask travel advisor to go to Abilene, ask travel advisor to take me to Abilene, and then finally, ask travel advisor to go to Abilene. So we're saying it's the same wording as in this first case, but then we're using a different voice. And in this case, we're actually using one of the WaveNet voices. Our default voice is a poly voice that's it's a male voice, and so then we're testing here with a female voice. And so I'm just going to play back this WaveNet voice. I think it's pretty impressive. This is provided by Google's text-to-speech. I think it sounds quite lifelike.
I am going to Boston.
So hopefully you guys can hear that. I'm just playing that back on my phone.
I am going to Boston.
It sounds great. To me, it's nearly indistinguishable from a human. I like to joke that I think it has better enunciation than I have. But either way, you can use these different voices. You can layer in SSML that allows you to do background noise scenarios. Simulate different accents, speakers, ages, and whatnot. And so in this case, though, we ran through these 3 utterances for this phrase, and they all were successful. So that's good. So then let's take a look at one that didn't do well. And I'm going to take an example. I'm going to go with Brockton. I like the sound of that. It kind of keeps us on a Massachusetts theme too, where we were talking about Boston earlier. So Brockton, in one of our cases, it mistook Brockton for Rockton. Now this is where, in looking at these things, there's some judgment to be exercised in how you decide to fix it. It misunderstanding Brockton for Rockton, assuming that Rockton is not a popular city. I'm not familiar of any destination called Rockton. Our advice would be add this as a synonym. So you can define synonyms for your slot values and add Rockton as a synonym for Brockton. That's a really good first level solution. You can get into more complex cases where when you're working with entity resolution, you might have multiple different matches, and you can do some custom handling on how to resolve those matches. You can do things with dialogues. There's definitely some more sophisticated techniques, but some of the most basic ones for improving it, it's just adding synonyms. You add those in, and that's going to often help with the performance. Another approach for really intransigent issues, I'm not going to say, I cannot promise any specific result, but we do work with customers on this, is actually providing feedback to Amazon on it, or Google for that matter, saying, here's where we're having issues, and do you have any advice, or can you tune this at all? We have heard of cases in which that that can lead to getting better performance. So there's a case that's pretty simple, I would say. One that I would say is less obvious. I was going to show, let's see, I think it's, or actually, here, I'll demo our search feature. All right. Oh, sorry, this is on the other test. So I'm going to jump over to our in-session test. So in this case, we were doing, we got 93.8%. And then we go over here, and for our in-session report, and let's look for Marietta. All right, I guess it was a different test. I saw an example in which it mistook Marietta for another popular city name, not so easily resolved, because then you have to make trade-offs around which one do you want to recognize. And that also goes to the point that if you're dealing with it where it's misrecognizing a term for another popular term, that's where if you correct for one, you can run into a problem with other ones. And so you really do need to be careful of that. And so I see there's a question from Jeffrey where he says, why was Maple Grove 0 out of 1 since there were supposed to be 3 tests? That's a great question. So the reason is we get errors occasionally in interacting with Alexa. And so basically we got an invalid response to that one. Typically in those cases, we just rerun the test and Maple Grove will run fine. Sometimes it can be something specific to the term that actually is causing problems. But the basic answer is for that one, we would just rerun it and see what the result is. And likely then we'd get valid results for all 3. But in that case, we're ignoring 2 of the results just because of some errors we're getting back system-wide. So once we've entered in all these results, or once we've gotten back our reports, this is really our starting point for making the sort of improvements and working the diagnostic process that I was explaining before. And starting at 93%, we might set a goal of let's get it to 97 or 98 or even 99%. But we start taking these cases, working through them one by one. You guys, by default, we sort by the worst performing ones. And so you just work through those and improve them as best you can. And after you're done with a round of changes, you run another test and see what the improvement is. And so it's a pretty straightforward process, I would say. And a few sort of early use cases. This is kind of a preview. In the coming weeks, definitely be on the lookout. We'll be adding a lot more use cases. But so we ran a bunch of tests for an entertainment skill. It's informational in nature. More than 1,000 values, slot values for the primary slot being tested. One that was typically invoked via one-shot. Had a lot of tricky names. And I would say, sort of colloquialisms. And the initial performance we saw there was around 75%, and we were able to improve it to greater than 85%, really with just a single round of testing and revisions. And I thought that was pretty impressive. A second scenario, this is a gaming skill, again, sort of a complex slot value in session instead. So this is a quiz type game. And the slot values are basically the answers to the quiz. And in this case, we started with performance that was around 94%. And after some testing and revisions, and I would say some really impressive work by the developer who had put the skill together, got it to greater than 99% performance. That's really an impressive uptick. And if you think about the users that are interacting with the skill, that 5% can make a huge difference, because that's an occasion in which it doesn't understand them. To them, it's going to feel, for that user, it's very frequently going to feel like a system error. So it goes beyond just, it's not a suboptimal user experience. It just can be a flat out error. And so in those cases, that's a very discouraging thing for a user. So to take that number down from 5% or 6% of the time to 1% of the time, or less than 1%, is amazing. And I can tell you in this case, the developer we worked with there really saw it as something that would be a competitive advantage. Providing that better experience for the skill is going to keep users engaged longer, keep them coming back more frequently, and overall cause them to like the skill more, better reviews. Just provide, an optimal user experience, which is really, I think, the goal for anyone that's building for voice or really building any sort of application. And so that's just going to take a look at another question here. So Tom asks, in the Brockton-Rockton case, if we decided to handle it ourselves in the back end, can we mark that test as successful? Yes. So if you have, I was saying we're not really testing your code at all. And that's essentially a true statement. We don't want to test your code with usability testing. We're happy to test with end-to-end testing. That's the right tool for testing your code, or the unit testing. But for the usability testing, there is a sort of code that we are interested in, and that's if you're doing your sort of own custom NLU. And custom NLU sounds maybe a bit fancy, but the idea is that if you're using like the entity resolution with slots, or even doing just some of your own magic, you might get back several different potential values. And if you then sort through and pick the best one, that's correct resolution. That's correct understanding on the part of the system. And we want to be able to measure that as part of our test. So to that end, we actually have a really simple way to do that, that we can tie into your skill so that we can see, okay, was this understood correctly or not, based on your own sort of custom little NLU post-processing. So yes, we can absolutely handle that scenario. And I see there's another question. Are you going to share with us this presentation? Yes, absolutely. We're going to share the presentation, and we're also going to share this video as well. So, again, no need to frantically take screenshots or anything like that. We'll make all these materials available. And then the last use case can be your own. And it's really easy. If you want to get started with us, just tell us what you want to test. The sequence, the intents, the scenarios, as I was mentioning before. You send us the interaction model, and we send you back the results. It's really as easy as that. We actually put together a simple form, which we provided a link to there. And it just basically has this data that we need to run a test. It's absolutely our intention that this is something that will be a self-service model where you can set up your own tests. That's something we actually have made available to certain beta partners already. But for now, if you just provide us this info, we'll run the tests. We can run them fairly quickly. And yeah, we're really excited to make this available to people. There is a charge for running the tests. So if you reach out to us, we'll let you know what the pricing is like. But we think that the pricing is really excellent for the value that's here. So like I said, really excited to make this available for folks. We do think that this is solving what we see and we think others see as really a critical need for voice. So we hope that you'll take advantage of it and find it as useful as we think it is. And so that's it for my presentation here. At this point, I'd like to just turn it over and see if there are any questions. And I'm going to stop sharing my screen. I thought I was turning on the video. Oh, okay. All right, so a couple of questions. Well, one, I see Tom says, great, that's the bit I missed. I mean, you didn't miss, I didn't explain that, but we will, we can test the interaction model just by itself, or we can test it with your custom NLU. Either way. I like the interaction model as a first thing, just because it's so easy for us to run those tests, but we can also tie into your skill. Either way, it's a neat thing. And I see there's a question: how do you prove the 94 to 99%? Could you explain a little bit more what you mean by that? I could guess at what you mean, but are you asking, how do we verify that those were the real results? Well, I guess right now I'm asking you to take my word for it, but we ran those tests through that. The results are private, but we shared them with the developer, and it's the exhaustive reporting about what the responses were like. I think it's amazing what was done there. The 99%, I saw that as a high watermark. To get it to 99 plus, I mentioned it to some of the folks on the AVS team, and they were, I was surprised by it, and they seemed surprised too. So I think that's an example of what's possible if you're really good at this, if you're really good at development. And I see there's another question. This can be done with other languages too. Yes, absolutely. And I should have talked about that more. But yeah, we can run this in any language that's supported by Alexa, pretty much any language that's supported by Google Assistant. And that's really a great feature. And I love this. Okay, so Tom says, less of a question than a potential feature request. It would be awesome if this would come with a library of environmental sounds that can impact recognition. I love these use cases, Tom. We would be delighted to help with something like that. Again, harking back to my speech recognition days, that was a big part of what I was doing. And you just do overlays of audio on top, generate some speech or take captured speech and then overlay other audio on top of it. If you want to simulate lots of different speakers talking in different noise environments, it's a brilliant way to do it. So yeah, that's I'll follow up with you on that. We'd certainly be interested in that. And you can already do that with the SSML, but there's like an extra level to go to. So I'd be curious to see what you had in mind. And I've only been looking at the chat. Let me see what's in the questions. So I see there's a question from Frank. How many different voices and environments should one ideally test? That's a great question. We are still identifying best practices, but I would say right now it's around 10, and we're trying to come up with some different packages. Like, okay, you have different speakers of different genders, different accents, as well as some different environmental situations, and sort of have, here's a core package of like 10 variations. And obviously this is sort of tailored for folks, but I would say in what we've seen so far, not everybody's coming to the table saying, gee, I want these, I have an exact idea in mind of the scenarios that I want. And so we're going to put together nice packages for people that'll basically be starter kits on it. We think that'll be very valuable. And I see there's another question. In terms of our user data, is there any data leak problem? It means that must we share ownership of the data with you? How's the safety? How will we protect it? Everyone is concerned about data and privacy with Alexa. I will just say in this case, the only sensitive data I think here, at least when we're talking about generated speech, is the interaction model. And we do hold that very closely. We're not sharing that with anyone. We're not leaking it in any way. In terms of the utterances, keep in mind these are being generated, by Poly or by Google TTS. It's not somebody's voice. It's not, if you're capturing audio in somebody's kitchen, you could pick up the conversation between my wife and I in the background, and that people are concerned about, the sensitive nature of conversations they're having. They don't want personal assistants listening to that. I understand those concerns. That's not the case here, though. This is just generated data. If we were simulating different environmental conditions, of course, we would ensure that those environmental conditions are ones that are not compromising anybody's sensitive data. So I don't think there's really much here, that's of a concern. And then I see if there's another question, if we want to check the voice problem, is there no privacy issues? I would basically say the same thing. It's really minimal in terms of the privacy. I'm happy to talk about that further, but I personally am of the opinion there's not, compared to your mobile phone, I don't think there's nearly as many issues with voice assistants, or smart speakers as with a mobile phone. And specifically for what we're doing here in that subset, I think that they're really negligible. Again, if your privacy was compromised, you're talking about the privacy of a computer voice basically leaking out. And thanks for that video, Jeff. I don't know that I've seen that before, so I'll certainly watch that myself. I'll be interested to see that. I have seen some blog posts from Amazon on that subject. So that's neat. Any additional questions? All our contact information is in the presentation. So certainly we encourage you to reach out to us. That form is there if you're interested in taking advantage of this testing. And we thank you for joining us. Like I said, we're very excited about this. Hope you are as well. And look forward to showing you more about what we're doing here in the coming months. Thank you, guys. Have a great afternoon.